Today we're tackling a really fascinating architectural puzzle. How do you keep your most critical data backups safe when you have to move them between the walled gardens of cloud rivals like AWS, Azure, and Google? I mean, this is the kind of challenge that can make or break your entire disaster recovery plan. So let's dive right in.
So just imagine this for a second. Your company's data is its absolute lifeblood. You need to back it up, but not just anywhere. You have to copy it from Amazon's cloud to Microsoft's, and then you need to be able to restore it inside Google's cloud. So the big question is, how do you build a system where you can actually trust these direct competitors to handle your data securely at every single step? That's the core problem we're going to unpack right now.
All right, here's our game plan. First, we'll look at the multi-cloud puzzle itself. Then I'm going to hand you the architect's blueprint for this whole mission. After that, we'll actually follow your data on its encrypted journey across all three clouds. And finally, we'll get to the good part, the huge strategic payoff for pulling this off.
So let's be real, using multiple clouds isn't some niche strategy anymore. It's totally mainstream. But that doesn't mean it's simple. Spreading your infrastructure across different providers, well, it creates some major headaches. You risk getting locked into one vendor's ecosystem, and maybe even worse, you open up this complex web of new security threats that are just incredibly difficult to manage. Okay, now let's put you in the driver's seat. For the rest of this explainer, you are the senior multi-cloud architect. You've just been tasked with designing a system that solves this exact problem. Your reputation's on the line, and, the mission is non-negotiable.
And here it is, your exact design challenge. Now I know it's a bit of a mouthful, but don't worry, we're going to break down all that jargon. The goal is simple. Create a backup that starts in AWS's S3 storage, gets encrypted with a special key that you control, then gets copied over to Azure's Blob storage, and can finally be restored on the Google Cloud Platform or GCP using a third key. The whole mission is about total control and total security.
Okay, so how do we actually do this? Honestly, the best way to understand it is to think of it like a journey. We're going to follow a single piece of your data as it travels across this tri-cloud landscape, and we'll see exactly how it stays protected at every single stage. You can really think of this journey in just 3 main steps. First, we lock our data in a super high security safe before it even thinks about leaving AWS. Second, we put that safe inside an armored truck for the trip over to Azure. And third, we use the final unique key to unlock the safe once it arrives at its destination in GCP. Let's break down each of those. Step 1. This all happens on Amazon Web Services. Before we do anything else, we take a snapshot of our data and we encrypt it using what's called a customer master key, or a CMK. The keyword here is customer. This key belongs to you and only you. It's like putting your data inside a one-of-a-kind safe and you're the only person on Earth with the key. At this point, the data is locked down tight. Now for step 2, moving the safe. We need to copy that encrypted snapshot from AWS over to Azure. To do this securely, we use a key from the Azure Key Vault. Now, what's really important is that this key doesn't open the safe. Instead, it encrypts the transport itself. So, if we stick with our analogy, the Azure key is the unique key for the armored truck that's moving your safe. The data itself, it's still locked inside, completely unreadable. And that brings us to step 3, the final destination, Google Cloud Platform. The armored truck has arrived. So now, we use a third totally separate key from GCP's key management service. This is the final key in our journey. It's the only one that can decrypt the original data snapshot, which lets you restore it and actually use it inside the GCP environment. So the whole point is this. A different, unique key was used at every single stage of the process. So, I know, that was a lot of keys and a lot of steps. You're probably sitting there wondering, why on earth would we go through all this trouble? Well, it's because this kind of architecture delivers some seriously powerful advantages that a simpler approach just can't touch. It's all about building a much smarter strategy. And this slide just illustrates the difference perfectly. If you stick with a traditional single cloud backup, your resilience is, well, it's vulnerable. If that one cloud has an outage, you are in big trouble. Your security risk is all in one basket, and you're basically locked into that vendor. But with our new tri-cloud architecture, you get high resilience, true end-to-end encryption across platforms, and the strategic freedom to move and operate wherever you want. It's a game changer. So to sum it all up, what do you really get out of this? First, you get ironclad end-to-end security. Your data is never, ever exposed in a readable state as it moves. Second, you have the ultimate disaster recovery plan. A massive outage at AWS or Azure? No problem.
Your data is safe and sound and ready to be restored on GCP. And third, you get true strategic flexibility. You're not chained to a single provider anymore. You can use the best tools from every cloud, and that gives you a massive competitive advantage.
And all of this really leads to a much bigger, kind of mind-bending question. We've designed a system where data can be created, backed up, and restored across rival platforms without ever being exposed. So, if our data can live securely, literally anywhere, what does location even mean for the future of information? It's a fascinating thought to end on.